Okay, continue with the explanation. Then check here the main have one function called system initialize. Yeah. To use this function, we need to declare it before. Then the system.h is the header that declares this function. And we check here system.h, and you can see the declaration like void system initialize void. Yeah, this is the, the declaration of the this function, right? And but this is not the function. Yeah, this is the declaration. This is the call to the function, but the real function is the C file. Um, then we're here navigate to declaration definition, and this is the system.c file is where is the, the, the function that then says void system initialize void. This is the function. What makes this function called pin manager initialize, clock initialize, interrupt initialize, interrupt global enable, function, system, core count, mode operations, etc. Why I explain you this structure? Because it's important for now and for future projects that find the mm, likely errors or bugs on compiler or executions. A lot of time I spend because some functions are not declared, etc. Okay, comes to the main. Come back. What makes this? No, delete my function. Just for example, this program don't make nothing for now. Start here. Go to this function. This function called this other function. We go to this function. What it means is initialize the pine manager. Then the pine manager is structures based our pin view to assign for E output option. And we can see here in this mode 3D. Okay, 3D. This set up the last bit of first bit of the port E like output. Yeah, because E in hexadecimal is the last bit like a 0. Then this is the clarity here, and all the other options for the ports of the GPI. It is not difficult to understand, but one more make the system initialize function. Clock initialize, then go to declaration implementations. Then we can see choose the supply the source of clock. The if we're gonna use PLL, if we're gonna use some prescalers, etc. All these registers we can find on the data sheets. Yeah. Then what makes the MCC? write all this code based these menus to avoid we find on each data sheet what make the ask to register PLID, PLD, the register, and how to place these bits on off. Okay. Anyway, it's important to know that to go faster, the MCC helps. Okay, saying the interrupts, go here, interrupt initialize. Still, we are not using some interrupts. And for understand interrupts, for understand interrupts, you have to know. For example, one program starts to run here. What happens if, for example, I press one button? Then um, this sentence, while one, it's a loop, infinite loop. It's run all the time. If I want to detect when I press one button, I can use an interrupt. Yeah, and an interrupt is a calling from the system that says or appears a pin changing, and then runs one routine to check what happens, and next come back to here loop. Okay. So for now, and for this example, we're gonna use a basic 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 instruction. Yeah. It's just blink one LED on off. Okay. Then I gonna use, for example, I gonna set LED one the name we have, and if we're gonna have pin manager, check here, and a pin manager no. Oh yeah, pin manager. Or pin, pin header. We can see here that on the header, two are some defined macros. Yeah, one macro is using define that when I play this code, instead this code the interpreter take this function. Yeah? Then, for example, you have play late one set height. Set the happy REO one. But if I'm sorry here, set the REO high. Yes, but we can use to let low, set low, or toggle. Because toggle change the state each time I call. But we can use first that one set high, but and the one set high. Verify the syntax. Okay. That one set high, yeah, set high. You want to copy. Next level one, low. Yeah. If you run this in this moment, um, you can see that the lead one is turned on off but so fast because each instruction is 1 o'clock. Then we can perceive some changes on this. Okay, and they appear unresolved. Okay. One of the problems of errors I found, or with or bugs, was I don't see. Look at that, we include this rather than system H. System H. It doesn't include other function like this other. Yeah. Then it's important, for example, MCC. MCC. Look at MCC includes all the, the all these includes. It's important to avoid this kind of errors by name. Include include here app which is generate file MCC. Okay. Once you add MCC, this call me MCC with all the callings. You can see the error that or the warning that appears on this. It appears. Comment. Look. Analyze. Say if I compile this, for example, click here in this button. I don't know, the hammer, and what errors appears is implicit declaration of let one set height because it's not declared before. MCC is the MCC that H is what have all the headers included in this. Then we include and compile paint and build again. Okay, then you can see okay, successfully compile it. Next, you can click on this button, run, and if you have connected your board, you can see that the RGB LED that they have for default is turned off while this is recording. And once this appears, program verify complete, the lead one should turn on. Yep. But really, it have a high frequency on this operation. Set high at um, at 8 megahertz, yeah, and set high, set low at other 8 megahertz. Then it's so fast. Then what we have to do to this add some delay. Okay, for delays, I have used one library called the peak 30. Then we can add here, include here. And before this, we have to define. Let me see if it's not defined yet. Clock. Ask now. Through manager node. System. And see. Okay, it's not the party. Okay. Close all these, and this pick have one's function called delay in milliseconds and microseconds. But before use, we have to declare or define ask the frequency ask is 8, yeah, and this order FG is F ask or divided to this 4 megahertz. Why this? Because this library use this definition. Okay, how I know this? Then we go to right click, navigate, go to declaration definition. Like pick, then we can find, for example, here a ask. FG, FG. Yeah. Not define it. G use FG. If we don't use FG, then um, it's generate an error. Okay, and in this case, the real intention is to use fask. Yeah, 4 megahertz. Then next we can place one in here. Main, main delay ms, for example. Yeah. Ms and macro and microseconds, milliseconds and milliseconds. Use milliseconds. Yeah. Add delay ms here and delay ms. For example, 50 milliseconds, 50, no, 500 milliseconds, 100 milliseconds. If you now compile this again, okay, successfully built, and now run on your board. Wait until the, the code is uploaded to the board. Okay, then you can now show or see the board. The GPIO, for example, I can, for example, video. You can see here. You can see here now the LED 1 is clicking half second on, half second off. Okay. Okay, Andrews, this is all for this basic application, right? Try to run this code. If you need, I can copy this code for you or let me know. But try to make all the operation. I'm sorry if I enlarge the videos, but I want to explain you each steps to avoid some loss on the process. Okay, I'm gonna make other videos later to you to help to make this same application, but not with delays, because delays have some problems. Delay take the control of the CPU, and no more can happens in this 500 milliseconds. And this is the idea. The idea is have other applications. Just set the change of all light with one event. Yeah, but here we are consuming milliseconds. Okay, I'm gonna make the same process, but we're gonna avoid this, delete this. Okay, or comments and comment lines with two slash, or we can comment blocks with slash and asterisk, and close with comment with asterisk and slash. Yeah, we're gonna make the same function, but not using set load, set height. No, we're gonna set let one toggle. Okay? Toggle function. Each time it's called, it changes the state of the LED. If the LED is on and it is called, then set the LED off. If the LED is off when it's called, the LED it's on. Okay, then make it again the test. Compile. Build and run. Okay, build and run. Okay, now I look at the board. Board is program memory and now okay, basic operation. Yeah, basic operation, not peripheral, just GPIO. Okay, Andrews, I leave you for now. I hope you can make all these tests. Please write me back to know if you can make this. Bye.